Hi, this is Vivek. Today we are going to discuss about moving charges and magnetism on online group. In this moving charges and magnetism, we can observe some experimental phenomena proposed by different scientists. The first one is a Oersted experiment. What is a Oersted experiment and observation? Very simple. We consider a current carrying conductor. It carries a current. When you consider current carrying conductor, this current carrying conductor produces a magnetic field around it in the form of concentric circles. Current carrying conductor produces magnetic field around it in the form of concentric circles. This is a very simple observation by the Oersted. Then they define the magnetic field. What is the magnetic field? How they are define the magnetic field? When a conductor carrying the current, when a current carrying the conductor, magnetic field is produces around the conductor in the form of a concentric circles. When magnetic field is produces around the conductor in the form of a concentric circles, therefore the space or the region which is surrounded by the current carrying conductor, the space or a region which is surrounded by the current carrying conductor, he defined as a magnetic field. When he defined the magnetic field, the phenomena what the Oersted is proposes is observed by the different scientists and introduced the direction of a current as well as the direction of a magnetic field by the various scientists. One is the Ampere is introduced Ampere's swimming rule. Then after the Ampere's, Maxwell can introduced by the Maxwell corkscrew rule. Then after the Maxwell corkscrew rule, again Ampere is introduced by the right hand thumb rule. Like that they are introducing in different scientists or various scientists in various rules for a determination of direction of a current as well as the direction of a magnetic field through a current carrying conductor. What the Oersted is proposes. Oersted is proposes a current carrying conductor produces magnetic field around it in the form of a concentric circles. This same phenomena can studied by the two scientists. One is Bayet and another one is the Savarts. This one is the scientist Bayet. Another one is Savart. These both are studied the same experimental phenomena and formulated by the law. Such law is said to be Bayet-Savart's law. For the determination and invention for the formula of a Bayet-Savart's law, Bayet and Savart can get the Nobel Prize in physics. Now, what is the definition for the Bayet-Savart's law? Then what are the importance of a Bayet-Savart's law? What are the mathematical equations for the Bayet-Savart's law? Then units. These we are going to learn now. Bayet-Savart's law. What are the observations by the both Bayet and Savart? Just they are taken infinitely long current carrying conductor. This infinitely long current carrying conductor, one end is connected to the negative electrode of the battery. Then the second end of the battery is connected through a one-way plug key. Then second end of a one-way plug key is connected to the another end of a infinite long conductor. This infinite long conductor of length L key is to make or break the circuit. Battery is a B, key can be represented as a K. This is a infinite long current carrying conductor. When we make the key, then current passes through the conductor. The strength of a current in the conductor can be represented as I. According to the Oersted observation, current carrying conductor produces magnetic field around it in the form of a concentric circles. According to the Oersted observation, this current carrying conductor or infinite current carrying conductor produces magnetic field around it. Therefore, for a determination of a magnetic induction due to this infinite long current carrying conductor becomes to the difficult. So that in this long conductor we can take a small current element of the conductor. That a small current element of the conductor can be represented as dl. From the current element dl, from the current element dl at a distance of r, from the point of p at a distance of r, from the point p, we can determine the magnetic induction dB or the magnetic field induction dB due to the current element dl. Therefore, this line joining the current element and the point P due to a magnetic induction, it can make or subtending an angle theta with the current element. When it is subtending an angle theta with the current element, then they are established, both Bayet and Savart is established relation for length of a current element, angle subtended and the distance, as well as a magnetic induction and the strength of electric current through the conductor. That strength of electric current through the conductor can be represented as I. They formulated four relations such as magnetic induction dB at a point P due to the current element dl is gives that magnetic induction dB is directly proportional to the length strength of an electric current, that should be the I. Magnetic induction at a point P due to the current element is directly proportional to the strength of a current. This is the first observation. Then the second observation by the Bayet and Savart, that as a magnetic induction dB is directly proportional to the length of a current element. That length of the current element is dl. Then the third observation for the Bayet and Savart, that as a magnetic induction due to the current element dl at a point P, a distance of r is directly proportional to the sine angle of the line joining between the current element and the point. Current element and the point, that dB is proportional to the I. And then finally the fourth observation for the Bayet and Savart, that magnetic induction dB is inversely proportional to the square of a separation distance between the magnetic element and the point where we can determine the magnetic induction. These are the four observations observed by the Bayet and Savart, introduced a law or formulated a law. It is said to be Bayet-Savart's law. To combine all these four relations, then we can get one relation for the magnetic induction at a point of B due to the current element. that magnetic induction at a point to P, that is dB, is directly proportional to the, then combine these all equations, that is current I, element dl, and the angle subtended by the current element for a point line joining between them as a sin theta is divided by r square. Therefore, the mathematical relation for the magnetic induction at a point P due to the current element dl by Biot-Savart's law is given dB is proportional to the ideal sin theta is divided by r square. This is the mathematical relation for the Biot-Savart's law. Now the proportion is there. We can remove the proportion, then we can get the constant. That is magnetic induction dB is equal to K into I dl sin theta is divided by r square. Here K is the constant of a proportionality or proportional constant. When K is a proportionality constant or a constant of a proportionality, then K is depend upon nature of units or the units or the system of units which we are consider. For a CGS system or CGS units, when we consider the CGS units, the value of K is equal to 1. When value of K is equal to 1, therefore magnetic induction at a point to P due to the current element dl is given dB is equal to ideal sin theta is divided by r square. This is the mathematical equation for the magnetic induction in CGS unit. Then we can express this equation in terms of a vector form. In terms of a vector form, that vector form is dB bar is equal to I dl sin theta is divided by r square into r cap. Here r cap is the unit vector. A vector whose magnitude is equal to 1, then it is said to be unit vector. Here unit vector is a r cap. This is the vector form for the Biot-Savart's law in a CGS system. Again, this can be written in a different manner, that as I into dl bar cross r bar is divided by r cube, because r cap is equal to r bar by magnitude of r bar. Since due to this, we can written in another vector form for the magnetic induction, dB is equal to I into dl bar cross r bar is divided by r cube. CGS system, we can write a vector form that has dB bar is equal to I into dl bar cross r bar is divided by r cube, because here r cap is equal to r bar by magnitude of r bar. Due to the value of r cap, we can get the vector notation for the magnetic induction in a CGS system. dB is equal to I into dl bar cross r bar divided by r cube. Now we can write in a SI unit. For a SI system of international unit, for SI units, when we have to write SI units, then proportionality constant K is equal to mu naught by 4 pi. When K is equal to mu naught by 4 pi, here mu naught is the absolute permeability of a magnetic field. The value of mu naught is 4 pi into 10 to the power of minus 7 Henry per meter, or this is a Newton per ampere square. So therefore, the value of absolute permeability of the free space or the air is a 4 pi into 10 to the power of minus 7 Henry per meter or Newton per ampere square. Then substitute the value of a K for the mathematical equation of a Biot-Savart's law, that is dB is equal to K into I dl sin theta is divided by r square. Then we can get in SI system a mathematical equation for the magnetic induction at a point P due to the current element dl is given dB is equal to mu naught by 4 pi into I dl sin theta is divided by r square. This we can express in vector form. When we can express in a vector form, we can express in a vector form. Therefore, the vector form of a mathematical magnetic induction at a point P, dB is equal to mu naught by 4 pi into I into dl bar cross r bar is divided by r cube. This is the vector form for the Biot-Savart's law in a SI unit or the SI system. The equation for the Biot-Savart's law in SI system, that has a magnetic induction dB is equal to mu naught by 4 pi into I dl sin theta is divided by r square. Now this Biot-Savart's law we can express in terms of current density. This I am going to express. Biot-Savart's law can express in terms of current density. It we can express in terms of current density. What is the current density? Current density can be represented as a J, that is equal to current by area. Current per unit cross-sectional area of the conductor is said to be its current density. Current density can be noted as a capital J. Now we can multiply with a current element dl, then without changing the value we can divide with the current element dl, then which is equal to I into dl is divided by A into dl. A is the area, dl is a small length. Therefore, it can be gives a current density is given IDL by it value as a dV, means change in a volume. Therefore, from this equation of a current density, we can write IDL is equal to J into dV. This is the equation for the IDL with respect to the current density. Then replace the value of IDL for the Biot-Savart's law. Then we can get magnetic induction dB, which is equal to mu naught by 4 pi into mu naught by 4 pi into the value of IDL is replaced by J into dV sin theta is divided by r square. Sin theta is divided by r square, that is equal to mu naught by 4 pi into J sin theta is divided by R square into dV. This is the change in volume, is the magnetic induction in terms of current density by the Biot-Savart's law. This we can write in a vector form, so that what is the vector form by the Biot-Savart's law in terms of current density. In terms of a current density, this can be written as dB bar is equal to mu naught by 4 pi into J cross R bar is divided by R cube into dV. This is the magnetic induction due to the current element dl in terms of current density J by the Biot-Savart's law. When we are expressing this equation in terms of a current density, that means Biot-Savart's law in terms of a current density, that equation can be written dB bar is equal to mu naught by 4 pi into J bar cross R bar is divided by R cube into the dV. This is the vector form for the current density, Biot-Savart's law in terms of current density.